Introduction to Engineering Free Body Diagrams, Lesson A. Ladies and gentlemen, if you follow this procedure and you can add and subtract, this will be the easiest thing you do ever. So here's the procedures. First of all, remember that right is positive and up is positive. Here's a free body diagram. All I want you to do is find me the net force acting on this object. All right, so what we do is we start by writing net force equals. I would go with the labels first. Highly recommend this. So, and I always start with whichever ones are on the positive side first. So this would be F1, it's positive, minus F2. Why the minus? Because that one's going that way, and that way's negative. See, because right's positive, that way's negative. Then I fill in the numbers. Net force is equal to F1, 80 newtons, minus 45 newtons. And the net force is therefore a whopping 35 newtons. And you're done. Blap, 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 just like that. And that's all there is to that. That is all there is to it. But what if there's three forces, Mr. Wellborn? Goodness gracious. It's going to be okay. It really is. Because you stick to the same procedure. See, here, you were probably looking at it going, just do 80 minus 45 and you're done. Why are you doing all this crap? Because the more complicated the problem gets, this crap helps make it easier. So, for example, here I would write net force equals, these are my positives, so I'd go F1 plus F2, these are little subscripts underneath here, and then minus F3. And then I plug in. One is 800 newtons. If you'd like to drop the units in this step, you can. Plus 600 newtons minus 2,000. Grab your calculator if you want. 8 plus 1,400. So this one, the net force turns out to be negative. Make sure I get this right. This is 1,400. That's negative 600 newtons. What does the negative mean? That means when it's all said and done, the net force is left. That's why it's important to put that negative in there. You could, if you wanted, instead of that, just say 600 newtons to the left. But negative 600 is fine. Do you think it gets that much more complicated when we go up and down? No. Just keep in mind that we're going to assume up is positive and down is negative. So net force equals, start with the positives, F1. Go to the negatives, minus F2. Then fill in the numbers. Net force is equal to 250 minus 130. Get a calculator if you need to. I'll take chance it. Let's see, that's going to be 120, I believe, positive. So 120 newtons. And that's going to be, you don't have to write up because it's assumed if you've written this, it's assumed that positive means up, but if you want to write it up, it's fine. All right. Oh boy. Oh boy. The only problem with this is space, so I'm going to grab, let's see. Here we go. Just going to grab a little space to work on this one. All right. So my net force, let's go with the positives. So 1, 2, and 3 are all positives. So F1 plus F2 plus F3, 4 and 5 are negative, so minus F4 and minus F5. That's the way that's going to set up. And then I plug in the numbers. Net force equals, let's see, 1 is 18 newtons, 2 is 34, 3 is 11, 4 is 40, so minus 40, and then minus 50. It's getting late. I'm not above using a calculator, so let's see. 18 plus 34 plus 11 minus 40 minus 50 It's negative 27. So the net force is negative 27 newtons. That means it is downward. Okay, so the net force here is negative 27 newtons. Not too bad. Go do that practice thing, and we'll try another set in a minute.